Let's have a look at question 6 in this video. So we know that the lifetime of a certain lamp, let's call it type A, is normally distributed with a mean of 5,000 hours and a standard deviation of 300 hours. We want to find out the proportion of the lamp that lasts between 4,700 and 5,525 hours. So let's draw this distribution and let's work with it. So we have the following. We have a normal distribution for the lamps for the lifetime with an average of 5,000 hours, so 5,000 hours, and the standard deviation is gonna be 300 hours. So this is in hours. This is one thing to keep in mind, that this is still in hours. Standard deviation of 300 hours. Now what we want to find out is a proportion between 4,700 and 5,525 hours. So the proportion between 4,700 and 5,525, we're looking for this area over here. Because we're looking for proportions, we know that to work with proportions, we must work with the z distribution. So we must standardize our values. So let's standardize them. If we're looking for the proportion between the following values, it means we're looking on the z distribution. We're looking on the z distribution over here with the mean of 0. And let's standardize 4,700 and let's standardize the other value. So 4,700, if we're gonna standardize it in the z distribution, that's gonna be the difference between 4,700 minus 5,000 divided by the standard deviation of 300. Divided by the standard deviation of the 300. And by the way, let me just write here the formula real quick so that we have it, so that we know how to guide ourselves. Now, by how many standard deviations does this observation differ from the mean of the population? So 4,700 minus 5,000, that's minus 300, divided by 300, that's equal to minus 1. So that's equal to minus 1. And if we have a look on the other side of the distribution, so we have a look over here, we have the difference between 5,525 minus the mean of 5,000 divided by the standard deviation of 300. And if we do the math over here, then that's going to be equal to 1.75, which means, so let's write it here below, just like that, which means that 1.75 is by how much the observation of 5,525 differs from the population mean in terms of standard deviations, And we're looking for this proportion over here. Now recall that the proportion in the z distribution shows the values to the left of that specific number. So we're gonna have the proportion that z is less than 1.75. So let's write that down. We're gonna have the proportion that z is less than 1.75, but then we only need it until the value of minus 1, so we have to subtract the following tail. We have to subtract the following proportion, meaning we're gonna subtract the proportion of the z being less than minus 1. And if we solve it, if we have a look in the table, in the distribution, this proportion over here is equal to 0.9599 minus the proportion that z is less than minus 1 is equal to 0.1587, and the difference between them is equal to 0.80 if we round it. So 0.80 means 80%. If we have a look at the answer key, that specific proportion rounded is 80%. So the answer is true, and that's it.